Hi, everyone. Today we are going to review some things from Algebra 1 that are going to be very important in Algebra 2. And we're going to call this topic our 7 graphs to know. All right, so some of these you might be very familiar with, right? So our first function, right, f of x, right, or y equals x. So this is a linear function. And our linear function is going to go through the point 0, 0, and it has a slope of 1. So f of x equals x. So this is our linear function. And our domain for our linear function, and we could do this in either set notation or interval notation. We're going to do it in interval notation. So my domain, my x's are in elements of negative infinity to infinity. My range, my set of y's, are also negative infinity to infinity, right? No restrictions. Number 2. So number 2 is our square root graph. So our square root graph has a little bit of a different look because remember, we can't take any square roots of negative numbers. So we also start at 0, 0. We have this small curve. Right, so f of x equals the square root of x, and you could just plug these into your calculator. So the domain, my set of x's, all my x's go from 0 to infinity. My range, my y values, because I can take the square root of 0 and get 0, my y values are also 0 to infinity. All right, my third graph to know. My third graph to know is let's go back and put square root in this one. Sorry about that. All right, my third graph to know is a parabola. So remember, my parabola does have a 0, 0 value, and we have a U-shaped graph. Right, this is our quadratic. And remember, we usually call this quadratic a parabola. So my domain, so my x's are an element, so there's no restrictions in my domain, so negative infinity to infinity. My y values, notice, do not go into that negative range, so they're going to go from 0, including 0, all the way to infinity. All right, my fourth graph to know. My fourth graph is my absolute value graph. And if you remember from algebra, my absolute value graph does have a point at 0, 0. And this is actually two functions in one. So it looks like a V, my absolute value function. So my domain has no restrictions, so negative infinity to infinity. And my range, similar to my parabola, is going to go from 0 to infinity. All right. Now, the next graph might not be something that you have seen a lot of. All right, so I'm going to sketch my set of axes on there. This is our cubic function. So our cubic function also does have a point at 0, 0. And it has a curve up here and a curve down here. So f of x equals x third. This is our cubic function. Now our cubic function has no restrictions. So my domain goes from negative infinity to infinity. And my range also negative infinity to infinity. All right, my sixth function. Now this is a cubed root function. Now you may not have ever had to graph this on your calculator, so I'm going to pull my graphing calculator out. And I'm going to go to y equals. And in order to get my cubic function in there, I'm going to go to math. And you'll see that number 4 is a cubed root. So I do want the cubed root of x. And we're going to graph that. Right, so again, we do have 0, 0 as one of our values, and we are now going to put that on our graph. All right, so we have something. All right, so again, 0, 0. All right, so we've got, there we go. So my f of x equals the cubed root. Cube root. My domain, I actually am not going to have any restrictions on my domain, so negative infinity to infinity. And my range also having no restrictions, negative infinity to infinity. All right, and graph number 7. Graph number 7 is a little bit different than the others because we have to have a base value in that graph. So notice that we have f of x equals 2 to the x. Now, when we put this into our calculator, we'll see that it's a little bit hard to see sometimes, but this graph is approaching, right, our x-axis here. We intersect at that point, which right there is 0, 1. And then we increase very, very quickly. So this does not cross the y-axis. All right, and this is an exponential function. All right, so my domain for my exponential function is negative infinity to infinity. My range, now remember we said it doesn't actually cross the x-axis, but it approaches 0. So notice I have an open parenthesis there, all the way to infinity. All right, so these are 7 graphs to be very, very familiar with. And then remember that from algebra, we talked about a lot of transforming our graphs. So in number 1, we are taking our quadratic, right? So we know this is a quadratic because we have that squared right there. And we want to talk about what happens to my function. So when I see a minus 2 here, that means that the center of my graph moves 2 units to the right. And this right here tells me that I'm going up 1. So 2 units to the right and up 1. Now I can put this into my graphing calculator. And if I want to use a couple of points to graph, I absolutely can. So I do know that my y-intercept is at 5. 1, 2, 3, 4, 5, just to help me get my shape in there. Right? Whoop, there's my parabola. So f of x, x minus 2 squared plus 1. All right, now my domain. Okay, so my domain here, x is an element of all real numbers, so negative infinity to infinity. But my range, notice, it got bumped up. So my range is going to go from 1 to infinity. All right, number 2. In number 2, we have a square root graph. But this right here, being under the parenthesis, tells us that we are going to move right 3 units. So 1, 2, 3. Now there's my point. And again, I can put this into my calculator to take a look at it. And my graph will continue on like this. So g of x equals the square root of x minus 3. All right, my domain of this function, notice that it goes over to the right 3. So my domain goes from 3 to infinity. And my range, notice that it's touching the x-axis, so it's going from 0 to infinity. All right, number 3. number 3, again, putting this into our graphing calculator. So negative x cubed plus 2. So it's telling me that I have my cubic graph, that something's going to be kind of backwards about it, right? So it's upside down. And this right here is going to tell me that it's going up 2. And again, I'm just looking at my calculator to sketch this. So I know that instead of going through 0, 0, I'm going up 2. And now I've got here and down here. So h of x equals negative x cubed plus 2. Now my domain, so x is an element of, so no restrictions, so negative infinity to infinity. And my range also, no restrictions, negative infinity to infinity. All right, number 4. So number 4, we have an exponential graph. So 4 to the power of x plus 3 minus 2. So we want to know what happens to my graph, right? So right here, this is telling me that we are going down 2. And this x plus 3 there tells us that we are moving left 3 units. So I can look at my graphing calculator, and I can get a couple of key points on there. So I have negative 2, 0. Let's get a new color here. So negative 2, 0 is 1. Negative 1, 2, 0, 1, 2, 3, 4, 5, 6. And let's get another one over here. We've got negative 2. Let's see, negative 3, negative 1. All right, that'll give us a nice picture of that. All right, so we now have our graph looking like this. So I've got j of x equals 2 to the x plus 3 minus 2. Now this one really should include our asymptote. So just like before, our asymptote happened to be the x-axis. This time we're moving down. Oh, I'm sorry, that should be down one more. Sorry about that. Ooh, let me fix that for you. Okay, so we are approaching negative 2. Sorry about that one. Negative 2. There we go. This will look better. Okay, so there's my asymptote. And let's get my curve back in there. All right, so approaching. There we go, looking much better. All right, so my domain for this function, so my domain, x is an element of all real numbers, so negative infinity to infinity. My y's though, right, my bottom bound there was negative 2. Notice it's not including negative 2 all the way to infinity. All right, let's try number 5. So in number 5, it's telling us our graph is upside down. And since that is in there, it tells us that our graph shifts right 4. And again, the calculator will tell you all of this. Now, if you can't find the absolute value in the calculator, let's do that one. All right, so negative. All right, so now we can find this in a couple of ways. So second, catalog, abs, and we wanted x minus 4. All right, so we know that it moved 1, 2, 3, 4 units to the right, and this graph is upside down. So m of x equals negative absolute value of x minus 4. So my domain, my x values have no restrictions, so negative infinity to infinity. My y values, though, this one's going to be a little bit different because we do have values that are going negative. This is actually going to go from negative infinity to 0 inclusive. All right, so number 6. Now we need to figure out what graph this is and figure out how to write this equation. So what I want to do is I first want to look at, okay, what is that point and what kind of graph is this? All right, so we know that this is a square root. But notice that our starting point, instead of being 0, 0, went left 2, down 1, 2, 3. Right, so we went left 2, down 3. So our equation, we can use y or f of x. Since we went left 2, we're going to say x plus 2. Since we went down 3, we're going to subtract 3 from the bottom. All right, in number 7, notice my center of this absolute value. So we know this is absolute value. And we know the center went right 2, down 3. So y equals, so if I went right 2, I want x minus 2. And if I want down 3, minus 3. Number 8. So notice we have a parabola. So this is a quadratic. And notice that our center there is 3, 4. So that means we went up 3. I'm sorry. Whoop, whoop, whoop. Silly me. It means we went right 3, up 4. So y equals, so this would be x minus 3 squared, since we went right 3, plus 4. And now this is also upside down, so I need a negative out in front of there. Let me fix that, make that look a little nicer there. So y equals negative, and then in parentheses, x minus 3 squared plus 4. All right, in number 9. So looking for my center looks like it went right 2, and this is a cubic graph. So if I have a cubic graph, so y equals, so if I went right 2, I do x minus 2 cubed. And remember, you can take all of these and you can type them into the calculator to double check that this would be an appropriate graph. All right, so given the following functions, graph the following transformations. All right, so what I want to do is I want to take this graph here and I want to do the function of x minus 3. That means that I move the whole graph right 3. So if this center was negative 1, 1, 2, 3, 4, 5, and I want to move right 3, 1, 2, 3, I now want my center at 2, 5. And then graph that parabola. Sketch it as best you can. So this would be the f of x minus 3. Letter B says I want f of x minus 2. So this means that I'm going to go down 2. So I'm going to go back to my original function. My center was negative 1, 5. Now my center down 2 and sketch my parabola. All right, so this would be f of x minus 2. All right, so the equation of the functions above. So that first one, having a center of negative 1, 5, meant that it went left 1 and it went up 5. So this would tell me I went x plus 1 squared plus 5. Now, if I'm going to subtract 3, so I take a look at letter A there. So x minus 3, so my center now we said was 2, 5. So this is going to tell me that I went to the right 2, so minus 2 squared, and up 5. And our last function, our center is negative 1, 3. So this is going to tell me that I have f of x, so this would be x plus 1 squared plus 3. All right, please let me know if you have any questions.